So the first homework problem you were assigned was to find the molar concentration of a solution in which 7.25 grams of hydrofluoric acid is dissolved in 20 liters of aqueous solution. So we start with 7.25 grams of hydrofluoric acid. Put that over 1. We need to know the molar mass of hydrofluoric acid. There's only one hydrogen and one fluorine. So this is the atomic mass of hydrogen. The atomic mass of fluorine is 18.9984032. There's only one of each of these. We've got two empty slots over here above the 3 and the 2. And so the molar mass is the sum of all the atomic masses of all the elements in the formula, so we're adding these together. Because of those two empty slots, we've got two insignificant digits. We're going to round those off. This is the grams of HF. We're going to actually round that answer off and actually use the rounded off answer. It doesn't have those last two digits. So this is molar mass, and the way that I ask students in this class to do this is that you always write the molar mass, but then also say that it's equal to a mole, because that's the definition. Molar mass is the sum of all the atomic masses of all the atoms in a formula, written in units of grams, and that's what is equal to a mole of that species. So I ask you to write this, because then with that equality statement, it makes it easier to know how to write the conversion unit you need to get turn the 7.25 grams into moles. And we do that by putting matching units and species and the number that goes along with it on the bottom here. And the other side of the equality statement goes on the top. And so we can cancel grams, and we can cancel HF. They can cancel just like X's and Y's in algebra. Then, in order to get to the molar concentration, we need to divide by the liters of solution in the problem. We have 20 liters of aqueous solution. And dividing by something is the same as multiplying by its reciprocal or putting it under 1 in a fraction. And we do the math. And the units we have left are moles of HF over liters of HF solution, capital H and capital F. I'm sorry, just liters of HF solution. And then we're going to round that off to the correct number of significant digits. For multiplication and division problems, you're going to look at all the measured or calculated numbers, and there are 3 of those, this one, and this one. Of the measured and calculated numbers, find the one with the least digits, least total digits, that will be this one, and round your final answer to have the same number of digits. So leading zeros are not significant. This is our first significant digit, 1, 2, 3, underline here. And we're going to round that number to 0.0181. And to simplify this a little bit, moles of some species over liters of that solution is molarity. And we can simply write that as M with a line or molar concentration. You need to know, sort of mentally know that you can switch out those terms, molarity, molar concentration. Okay? So molar concentration of HF solution. All right. number, unit, species, and cancellations are all have a value to us in terms of solving this problem. So number, unit, species, and canceling both of those over 1. Number, unit, species, cancel, cancel. Since we're putting this underneath 1 to divide, we're going to give that a point value. Number, unit, species. That you're coming up with the correct answer, the unrounded answer, underlining insignificant digits. This set of measurement units and species and things like that, I'm going to count as one thing, because really, if you just wrote molar right here, it would be okay. All right, there's nothing different about writing all of this and writing this. It's the same thing. So somebody just put M with a line under here, we'll accept that. Does that make sense? Okay. It's important that you have it, but we're going to accept molar if you want to put it there instead of all of this. I like to put it there just to make sure I've got all my units right when we're done. And the arrow showing you rounding off, rounded answer, unit, species. The calculation of molar mass is important. Putting down the two elements, the atomic masses. Since we're multiplying by 1, I won't count these as more points, just the fact that you put the molar mass, because you could have just added those together. Number, underline, unit, species, arrow showing you rounding off, rounded answer, number, species, equals 1 mole HF. All that's important to us. So all those are worth points. So that's 16 points for this part of things, 20 points for this part of things. So this problem, the whole problem, is worth a total of 42 points. Okay. Then the second homework problem was to find the pH of a solution for an acid, a strong acid with a has one hydrogen ion, or it's called a monoprotic acid. The problem was, if 2 grams of hydrochloric acid is dissolved in 10 liters, it should have been, of aqueous solution, what would you expect the pH to be? So we start with 2 grams of hydrochloric acid. Need to find its molar mass. Atomic mass of hydrogen, atomic mass of chlorine, and 1 of each of these. Add them together, recognizing you've got 2 empty slots over here. So this is grams of hydrochloric acid. I'm going to round those last 2 digits off. Let me see what you got. Okay. Yeah, put it in your file. Put your name on the top line, would you? Thank you. Do you have your homework? I need to give it to me to grade then, I guess, at this point in time. All right. Okay, so now that we've gotten our molar mass calculated and rounded off properly, we've got an equality statement. If you do it the way I teach you to do it in this class, with the equality statement we can convert the mass of hydrochloric acid we're starting with into moles in the same manner that we did it on the last problem. We can cancel units and species, and we need to divide by the volume of the solution in order to get molarity. Well, the volume of the solution in this case was 10 liters. You got 2 pages? Or just,
This is my
is your what? Oh, okay. Let me put this over here. Okay, and so from this then we can calculate the molarity of the solution. That's the first step in finding the pH. Units we have left after canceling are moles of HCl over liters of HCl solution. We're going to round it to 3 significant digits because the number, measured number or calculated number with the least digits is this one. It has 3 significant digits. Leading zeros are not significant. First significant digit is this one. 1, 2, 3, and everything else is underlined because they're insignificant. And round it off to 0.00549, and that's molar concentration of an HCl solution here. Okay. Then we got to calculate the pH. pH is the negative logarithm of the hydrogen ion concentration. Okay, so pH is the negative logarithm of the molar concentration of a hydrogen ion. And putting it in brackets means molar concentration of hydrogen ion concentration. Using hydrogen ion concentration is an Arrhenius acid-base theory representation. Bronsted-Lowry would represent it as H3O plus, which is hydronium. For a strong acid with only one hydrogen ion to be dissociated, for a strong acid with only one hydrogen ion to be dissociated, the concentration of hydrogen ions is going to be the same as the concentration of the acid. And that's because I've got a strong acid here, and when I dissociate it, if all of these break apart, and that's what a strong acid does, all of them break apart, I'm going to get one hydrogen ion. Molar concentration is the number of particles in a solution, and that's if I've got this many, or I've got 0.00549 moles in a liter of this, and all that breaks up, then that's a 1-to-1 ratio to this, so I'm going to have 0.00549 moles of this in a liter of solution, and that's molarity of this. So because it's a strong acid, because I've got just one proton, then we can calculate the pH as, only in this case, or in cases like this. So negative logarithm of 0.00549, and we find the pH to be 2.260427, and then 5 goes on and on and on. And so we're going to round that to 3 digits because we're going to use the same rounding system as we use for multiplication and division. There actually is a different rounding system for logarithms, but in a high school chemistry class, I usually just have you use the same rounding system as in multiplication and division. So since our number started with 3 digits, I'm going to change this to 3 digits. So we're going to say the pH is 2.26. Okay? No. The main thing is that they know that they have the original calculation here somewhere, either negative log of this or negative log of that or negative log of that. Okay? That's going to be worth points there. Doesn't matter which one of those 3 they do. Okay? Because it is a strong acid. And then they have to show how they calculated it down here. Okay?
So that's what I was confused. So with the log for the pH, we just put in brackets the acid and the molar mass of acid.
Yeah, brackets are just a way of symbolizing molar concentration of what's inside. That's all it is. It's just a way of, it's sort of a shorthand. So I have to write out the words, molar concentration of, I just put that symbol in brackets to show molar concentration of. Just a shorthand for chemists. Okay? Okay. That's all it is. All right, so we got all this stuff in cancellations here. You got to have at least the original one of these three, this one, or you could say pH equals this. Any one of those three will give you the points. There'll be 4 points for that. One for this, one for negative, one for log, one for the symbol, okay? Any one of those three will give you those points. All right? And then you've got to put the, let's see, negative log of the number, unrounded answer, arrow, underlining arrow, and final answer. And you add all that up and you get 45 points for this. So the total for all of the homework is that 42 and 45. It comes out to be 87 points for all the homework. I've been sick for almost, well, it'll be 3 weeks coming Monday. If I stay sick then. Let's see. All right. Any questions about that? No. If you didn't do well on this, I have makeup problems written out for you already. Yes. I'm trying to put this on the recorder. Thank you for telling me that.